Thank you for joining us today. I'm really glad to see you. And today, actually, first time I will speak about this topic, but this topic I really love, and actually, I start my public career from this topic. And this is CI/CD, so continuous integrational system for QA. So I think you heard a lot about different possibilities to use continuous integration, continuous delivery systems from developers' perspective or from DevOps perspective. But today, actually, I would like to present you my guide. So I really tried to summarize my whole experience from the past. So all time I had this task to set up from the beginning, from the scratch, CI/CD system, which will solve this task, automated quality control. To really useful algorithms with particular steps that you can follow. So actually it is the main idea, and if you have any questions in the end, we have time for it. And right now, let me start from introducing myself. So I'm Alex Pishi. It's my professional nickname because my surname is really difficult to pronounce. As for my background, right now I'm software developer, engineer in test at JetBrains. And I have been working for a really amazing tool, JetBrains Aqua IDE for test automation. In my experience, I have been working from these different difficult tasks, how to set up automated quality control systems in more than 20 projects. Which actually allows me to prepare this algorithm for you today. And in general, I'm a big fan of process of test automation, in general of process automation. So if I have this rule, if I have to do some action twice manually, I always try to automate it. Of course, I will double check how much it will cost for us, but in general, I have this approach. And if you want to find me in different social media like LinkedIn, Twitter, and etc., you can find it according to this QR code. So, let's start from actually typical view on continuous integration, continuous delivery system. So, how normally we can approach it? So normally we have kind of such a view, like first of all, why we need CI/CD, because we want to automatic deploying, and that's totally fine, of course, because right now we have very competitive markets, so we really have to release our features as soon as possible. Normally it's several times per week, so of course we want to support this fully automatical deploy. A big part of CI/CD, it's unit tests, but I would say it's very basic implementation. So it's like the first layers, it's unit tests. And after that, of course, sometimes we introduce into CI/CD different system checks. So it can be system temps, basic one, for example, UI tests, and normally that's all. So our CI/CD pipeline contains three basic layers like automatic deploy, unit tests, and system checks, and that's all. But actually, I'm trying to suggest approach where we can put into our CI/CD pipeline much more useful functionality for us as a testers. So what it can be? Let's try to look to another picture. So first of all, how in general our process looks. So we have a new feature developed. For example, it can be one new feature about compressing store images. Yes, we want to improve the speed, so we try to compress our images. What after that? normally after that we can do quality metrics measures. So we try to measure our quality metrics to understand the dynamic, the difference between previous state of our application and current state with this new feature. So for example, we notice that time to respond increase 34%. And after that, what we can do? After that, we can call our quality gates. Quality gates is this type of gates when they can say, for example, this metric has to be like on this level, and if this metric doesn't meet this requirement, so in this case we don't allow you to go further in our pipeline. So for example, we allowed in our quality gates only plus 10% of time to respond increasing. So actually, yes, looks like this too much for us. And after that, responsible people should be notified. Yes, because that's problem. We have new feature which right now gives us much more time to respond, which we when we expected before. So, for example, it can be automatically sended message to some performance channel. It can be Slack or Microsoft Teams, any possible messenger, team messenger. And after that, pipeline artifacts collected, which is really important step, because on this step we can save important information, first of all, to analyze this case, the second to reproduce this case, and the third to analyze history of changes, because in future we will probably can face the same situation with the same changes in different metrics. We can analyze previous data, historical data, which is really insightful information for us. So here in our particular example, we can, for example, save node settings and our benchmark log, because if we just measure time to respond, it means that we had some data, so some benchmark. And after that, we can call next process. So it can be different processes, depends on the previous stage, depends on the feedback from quality gates. So for example, in this case, we would request developers update, because this feature actually doesn't meet our requirements. And this type of process we can call automated quality control system. So it's not just unit tests and like green or red or failed or passed and that's all. It's collecting different metrics, and we actually have to invest a lot of time before to set up such type of pipeline, because it requires really good understanding of all possible processes in the team, on all connections between these processes, and it's a really huge work, but in the future it will help us in terms of this like continuous feedback from our system, and this system is very like autonomous. So it means that it can exist without us. It can validate new features, it can measure different metrics, it can make some important decisions based on the metric results, and after that it can also notify responsible people, teams, actions, processes, whatever, and after that it also can call the next process. So it really works without us. Okay, it can sound really cool, but of course you would ask, okay, how we can achieve it? It sounds very difficult technically and also in terms of processes. Okay, I will try to show you different steps you can follow, and you can set up this type of quality control system. So where we should start? Okay, I just mentioned that actually we have a lot of different processes in our team, and right now I'm gonna to show you a very high level picture of very simple sequences of processes, just to show you that actually the first step should be to analyze whole processes in the team. So for example, what processes do you need? And we have different processes. For feature, we can have requirement testing. So it's the first stage of our shift left approach, when we just receive our requirement list, and right now we have this requirement testing. Also, we can have functionality testing for features, per feature. Also, non-functional testing, so to measure, just in our previous example, to measure how this feature affected our like performance state, also load testing, and so on and so on, security testing, UX testing, a lot of different non-functional checks. Okay, and it's only for feature. What we have for product versions, because we have features, and when we have a lot of features, they are collected into one like product version. So in product version, we have UAT testing. So when we try to understand if all our user acceptance criteria actually met. After that, we can also have alphabet testing. We can have functional testing for whole product version, because here we can check how our features work together, like integrational testing. And it's only for product version. Non-functional testing, the same. In general, effect on performance, also when we have bunch of features, not only one feature. So that's actually a lot. And also for releases, which was initial idea of CI/CD. So it's configuration testing, because sometimes it's really very situation when we actually tested everything and we are quite sure about each particular feature, but finally for some reason we just have incorrect configuration on our production environment, and it can of course lead to different problems. Also compatibility checks. So sometimes for example, if we have a lot of parts of our application, we can test each particular part independently, but after that we can realize that together they don't work. And availability checks also, and it's just few number of processes which we can follow. So that's why I highlighted one more time that we should start from processes map. So how it can look. For example, the basic implementation, we have our developer team, which produce every day some features. It can be new feature, and after that we have process to analyze this new feature. For example, if everything is fine, everything is green, we can go further. Also in our feature, the same. If everything fine, everything is green, we can go further. New feature, the same. We will check the state of feature, and for example, in the middle, we just realized something is. For example, we don't have good results with a pass rate of automated tests or something else, requirement doesn't meet or something, and we should return this feature to the previous stage. So after that, all these features, they collected together and start UAT testing, as I just mentioned, for example, the testing of whole features together. And it's the next process, it's separated process. Because why it's the next process? Because it has different type of like source of process, so a trigger or manual action. After that, it has different stages of process, and after that we have different like decisions based on process result. So for example, if with UAT testing everything is fine, we can go further, and it can be already release process, which is the most important here, for us. And finally we achieve our production, everything is great. So it's really very simple example of one of type of processes we can follow. But the most important thing is, before we start to build our real automated quality control system, is to write down this process map. And in general, even if you wouldn't start preparation of this fully quality automated system, in general, it's really good exercise once to write down this processes map to see where is the bottlenecks and what can go wrong here. So of course, a lot of different our processes, and which type of steps we should follow here. So we actually have to follow below steps. So, as I said, write down all processes in your team, really good exercise. After that, choose the most crucial, expensive, and long processes. So, of course, unfortunately, we understand that we don't know normally enough resources to cover all these processes, so we have to prioritize it somehow. So, first of all, we can prioritize it based on money, how much money we spend, also based on in general impact, so if it's crucial or not, and based on also how much time it takes. So in general, we really would love to speed up really long processes and automate it. So after that, we can implement automatic testing control system, and we will start right now from this part, automatic testing control system, how it looks. So we should follow these steps. Of course, it can be adjusted to different teams, but it's just some common approach from my personal experience. So first of all, we have these preparation steps, which it can be really important topic, but we will go further to it. And why it's important, because actually I have been teaching for 4 years a lot of different QA automation engineers, like middle, senior level, lead level. Big problem, no one check business metrics, quality metrics, and when quality gates. So it's preparation step, and we will further dive into these preparation steps a bit deeply. So after that, pipeline steps. What we can have here: pipeline triggers, which type of triggers, how to choose, pipeline stages, pipeline criteria, also very important, because we have several criteria of really good pipelines and bad pipelines. And feedback steps. So these steps includes metric collection, system notification, and call to the next process. And actually after that, we would start again. So this process, like we will start again, but from the next process. So it's like kind of this map, which is going from the first stage of feature delivery, or maybe even earlier, from analytical part to the release. And actually, in the perfect situation, we have to prepare this type of research for every delivery process. Yes, what can sound, of course, a bit heavy, but okay, it's ideal situation. Preparation steps. Let's start from preparation steps. What we have here. Where to start? It's really a good question, because I think if you have never built any type of CI/CD pipelines in general, and especially for QA purposes, you would definitely face this question, where to start. And I'm gonna actually ask you one question, which is, I think, really important. But tell me, please, why do we need in general test automation? And I will try to check it in chat, if you can write down it in
Recording
chat.
Stopped. Recording in progress.
So I'm actually waiting for you to answer this question, just your hypothesis. Why do we need test automation? To make sure that features continue work even after deploy. Yes, but my question even a bit deeply. So I mean, in general, why would business hire us as a test automation engineers? Less manual work, yes, definitely. But also, it's really questioning. I mean, like, to save time and money. Yes. To ease the time-consuming regression testing, unattended test run, time save and test coverage for speed, less manual work. Yes. So For regression testing, crucial to ensure that previous functionalities remain intact after new changes or updates have been implemented. Yes, great. Actually, I really agree with your point. But I would like to start from the 1 second. I would like to start from one question I always have been asking when I given some technical advice for different companies, because when I speak with business owners, actually they even don't know what does it mean to test something automatically, but in general they don't care the most important thing, and only one thing they care, that's I think not secret for you, that's actually money. And business really interested in growing the number of users finally, because they want to earn more money. And maybe it can sound for the first glance that it's really, I mean, this reason kind of far away from us, but actually no, because if we are aware about business goals, we know how to help business to achieve business goals using test automation as a tool. And that's actually why normally business hire us. So that's why that's important to understand business metrics. For example, business metric can be like more paid users for this quarter. Okay. And that's why it's really important to also be aware about product metrics, because product metrics, it's a bit something more product oriented. For example, plus 25% of retention. And after that, actually QA automation can be used as a tool to achieve product metrics. Because in this case, in general, when you follow this approach, it's much more easy to ask for promotion, to present your work, and etc., and not to write tests just because you are QA automation engineer and you have to write automated tests, because sometimes you don't even need these automated tests. That's why it's important to understand the final goal. So when we create our system, we can help our business to achieve this state of more money by achieving business metrics and by achieving products metrics. So it's kind of this chain, So, okay, that's really important to understand or to remember this part. But what's about quality metrics? How it can be related to product metrics? And this is really, really, really cool, I think, main insight for me personally, that quality metrics have to be built on product metrics. For example, you have your product goals for the quarter, and in metrics, like you need plus 25% of retention, etc., etc., etc. So after that, you are thinking how to achieve these metrics by providing the best quality. And here you can analyze, for example, if you increase your coverage for 15%, in this case, the possibility of achieving product metric is really high. So let's dive. And for example, the same with. Yeah, it's the same. Okay, so let's dive to list of metrics. What it can be, for example. For example, we have business metric, revenue growth, 20% overall revenue growth for the company over the quarter. Calculation, somehow it's calculated, so yeah, we have special formula for it. And after that, based on this business metric, we have product metric. Normally, we can discuss it with product owner or someone responsible for this calculation in the team. And the goal is increase user retention to 40%. And we have business outcome, which is exactly like of course, it's not, we cannot be sure that 100% we will achieve it, but it's not our hypothesis that if we do this, and this in terms of product, we will achieve such results in business. Okay, and after that, we as a quality engineers, we can build based on this product metric user retention our already a quality metric. So for example, quality metric can be here personalization errors. So we are going to reduce the number of errors to 0.1% of all recommendations. And product metric outcome, it's also our hypothesis, will be like exactly what we need, increasing of user retention. Okay, great. So we have quality metric here. And after that, what we have to do? We have to build our quality gaze based on our quality metric. So for example, if we have some quality metric like 98% of pass rate for the new feature, so quality gate will be if this metric is less than 98%, we fail and notify some channel. Or if it's higher, so we pass and we can go to the next process. So in our map, you remember, it would be like you add and then release. Okay, so what about quality metric and quality gates? For example, if we coming back to our previous example, we have our personalization errors. We already set up this quality metric based on product metric, based on business metric, and right now we are setting up our quality gate. So here, for example, if we have less than this metric result in quality gate, so we say no, it's not okay. So not less, higher. So it's not okay. We gonna to fail our pipeline, and otherwise that's fine. So metric as we expected, lower than 0.1%. In this case, we go further. So that's I hope it's not very complicated example, but I'm just trying to give you the main idea that actually it's really good to think about final business goals. And if you are not aware about all possible quality metrics, you can follow this website here, because I collected all quality metrics with small description plus formula how to calculate it, because it's also a popular question how to calculate it. So yeah, that's the main idea. So if we try to conclude this part, what we have to do, I try to, because it's just small talk and I try to give you main idea, of course, not like all these formulas, but again, you can follow the previous link. And first of all, you have asked your business for the next quarter year. So depends on your size of your team. If you have been working in really small startup, probably you are really in touch with owners and all these important people. If you work in a big tech company, maybe you have product owner and he is aware about all these business goals. After that, you should clarify product metrics with product owner and build quality metrics based on these product metrics. Or if you have QA lead definitely has to be aware about all these metrics if he or she is not aware. So in this case, you can kind of try to push them a bit to clarify all these important things. And finally, we set up this quality gates based on the quality metrics. Why we need it? Of course, because it's an important part of our CI/CD pipeline. So when pipeline steps. Okay. The next step, as I said, it's pipeline steps. So the main question. What the flag of the process start? Because when you try to build this draft of your pipeline, your first question would be, okay, so how we understand we have to start our pipeline? So we have different type of triggers. We have Git events. So for example, it's really basic. New merge request, new commit, new changes folder, and you have a lot of different type of adjustments. So actually you can set up very custom Git event. I don't know, if this particular file has new line on this number line. I mean, you can do any customization you need based on your business processes. Okay, so technically everything is possible. Then you have manual actions, and I would say I would prefer to do it really if it if it is required. For example, sometimes you have some main responsible QA for this day who is checking all merge requests, and he can set up manually like this is fine, we allow this pipeline go further, or we allow this pipeline to call in our pipeline. So it's manual start, personal approve, message in Slack also can be different manual actions and can be different source of manual actions. And after also another type of triggers is when previous pipeline trigger this new pipeline. So if we have this chain of processes. And so you have to just choose which method is the most appropriate for you based on this whole process map. Okay, another important question: what type of stage would we have? And right now I will give you kind of this very common picture, high-level picture of all possible stages, which normally we use in mostly all teams. So first of all, it's critical checks. What can be critical checks? Normally it's something related to build, because if build is not completed, no any reasons to start with more high-level checks. Compilation problems, the same. Configuration problems. So very critical checks when you don't have, it doesn't make any sense, just go further. And the next stage normally it's code quality. What is related to code quality? It can be check style, it can be linters, and if you are QA engineers, I really highly recommend you to be aware of all progressive linters, because nowadays linters are really crazy. I mean, they can check a lot of different things. I mean, in terms of security, in terms of licensing, in terms of course, basic things like if you have some area of code where is a high probability of bugs. So, I mean, a lot of different really cool heuristics, so you can follow it. The next stage is functional testing, and it's unit tests normally, based on our testing pyramid, integrational tests, system tests. I think it's something basic, so you already know it. And the next stage is non-functional testing, a bit less popular because still not everyone has non-functional checks as a part of CI/CD pipeline. A lot of people still do it manually. And here we have performance tests, security tests, availability tests, all this type of non-functional testing. And after that, finally, actually, we can use different custom heuristics. I just give you several examples, like issue state. And this integration is really useful when you have in CI/CD pipeline information about related issue, like state, which type of parts of system affected, also who is responsible, who is developer, so you can call him, you can mention him in code review, so a lot of different things. And also, for example, bugs probability was funny heuristics in my experience when we tried to check correlation between probability of bugs and also developer. So I mean, it can lead to some cool insights or not. Just example of how crazy can be heuristics. Okay, so what criteria of the effective pipeline, which is this topic is really also important because we can set up pipeline, but how to create really cool and at the same time useless pipeline if you don't follow this criteria. So which type of criteria? First of all, fail first approach, and it's just the example I mentioned before. Pipeline has to fail when it's obvious that the process does not meet requirements. So, for example, just before, if your code cannot be compiled, there is no any reason to start unit tests. Time of execution is really good, important factor because pipeline has to be finished in appropriate time. What does mean appropriate? Because it sounds very subjective. So time that does not affect our processes. Because, for example, if I'm developer and pipeline is really cool, checking everything, blah, 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 but at the same time, I cannot deliver my features like normally, properly, because I have to wait 5 hours for each commit. It sounds like, yeah, something that actually doesn't help us, but even make our work worse. So another point is also reliability. So that's, I think, one of the most important, because otherwise our pipeline and all our before steps doesn't make any sense. So pipeline has to provide only true positive feedback. So actually, in terms of metrics, it means low flakiness rate, because the situation when like pipeline gives us feedback, but this feedback doesn't show reality, it's really bad situation. Because why we set up everything? We set up this system because this system should provide us objective high level picture of the quality status of our product version. And if flakiness rate is really high, so the same as with auto tests, doesn't make any sense. Okay, so it was criteria for the effective pipeline. And finalize our pipeline steps. What we have to do: first of all, find correct triggers for the process. It can be one or several triggers. Design pipeline stages based on metrics and checks. So yeah, we know which type of metrics, because we already have done our preparation steps, right? We know which type of metrics is really important in our process. So we have to create this pipeline stages based on this fail first approach I just mentioned. And measure time flakiness rate to confirm pipeline quality criteria, because yeah, we just discussed it. So I think you got the main idea. Okay, fine. So I hope you're still here. And yeah, we are going to the last stage, feedback steps. So first of all, metric collection, very important stage, because actually every time we run our processes, we got really insightful information about everything. Of course, depends if we collect in this metric or not, because yeah, metrics they're not sending automatically to, I don't know, some storage. We have to set up everything. And what we can do here: so the basic implementation, we can use statistics from the reports. So it's some test coverage. If we use Java, like it's JUnit reports, TestNG reports, for coverage Jacoco reports, rest assured Swagger coverage report. Everything is reports from the tool, ready to use. Test results and history and metadata, so it can be Allure and so on. Also, we can create our execution collectors. As I said before, sometimes we have to upload some specific data, and we have to set up this type of collectors inside our code. So, for example, how many times we try to run our auto tests, performance data, and some artifacts. Normally, we attach it also manually: screenshots, HTML sources, some logs from HTTP methods calls, and so on. And also we have custom scripts. So for example, as I said, issue status, we can also collect it inside our pipeline and publish it after that. Deploy status, and so on. And after that, the also important question: where to store all these metrics, because of course you can collect it to some simple txt file, but it's not really readable, not really usable. And here we have different approaches. Ready-to-use solutions, I just mentioned, it can be Grafana, so we can send to Grafana different metrics. We can use Allure reports, which automatically collected a lot of metrics from test automation, and some other different ready-to-use tools like SonarQube. You have a lot, and even you can create your own report. So custom solutions with own reporting. In my previous experience, in different teams, we used Notion dashboard. So we actually we send this data customly to Notion, because Notion has API, so you can just send data and you can build any dashboard you want, and it can be also it can be updated automatically in real time, which is also cool. HTML reports, also in our team we built our own HTML report because we have to show all these metrics. So you have a lot of different solutions. Also you can try to Google data report tools, and you have just to send in the appropriate format all this information. So yeah, this type of monitoring really cool, because yeah, as I said, you'll have all these insights. But the basic implementation at least collected even to TXT file. Okay, yeah, because it's really tough when you are like you would have, I mean, when you don't have history, you don't have anything. You cannot even to analyze dynamic of, in general, quality of your application. Okay. After that, how to notify responsible people. Here also the main idea. So first of all, you have to understand the level of escalation. What does it mean? So you have different type of levels of escalation. For example, it can be not super important metric, or it can be the difference from the ideal state of metric, like not so big. But if it's really huge, you're like, okay, we have to call I don't know, our engineering manager, and we really have to call. So you can use even such tools like Oops Genie, which will really call to person anytime. So yeah, it's in the highest level of escalation. Or it can be a more simple level, so you have different channels in your Slack or other messengers, and you just send automatically a notification with all important information. And yeah, after that we can do some actions, so call or sending messages. So that is really, like, I mean, it sounds very high level, very easy. Only one important thing, technically maybe a bit difficult sometimes for people who never done it before, to implement this first automatic sending. But normally all these messages have API, so you can just use API and to send this data. And also, for example, if Slack, it has Slack bots, so you can create your own bot which will manage it. So yeah, in general, in test automation life, I think in my life I created more than 40 Slack bots for different reasons. So yeah, that's test automation life. Okay, so call to the next process. Yeah, as I said, it can be automatically and manually. And how to understand our next process, just come back to your process map if you have done really good job. So right now you have all this information, and you don't need to spend a lot of time to understand what is the next process. Okay, fine. So steps to do here: choose the best way to collect all metrics, figure out responsibilities and call to actions, and set up a call to the next process based on process map. Very, I think, transparent, easy. So yeah. Okay. As a result, what we have? We have automated quality control system. Right now, everything is very theoretically, but it's the idea of this talk to provide you the main, generalized algorithm, and then you can maybe get some insights. So we have our developer team, and right now, any action will lead to calling this automated quality control system, which will prepared stage priority, so our different stage of pipeline, automatic metrics calculation, so calculate all metrics, implement instructions, so okay, we have this metric, we have to do this and this, implement all instructions, and collect some data and call to the next step. So really the whole process automated. And we can look at this picture as a CI/CD as a tester tool, and after that, finally, we have continuous feedback about system quality status, which was our initial goal, actually. So yeah, we just achieved our initial goal, happy end. Of course, not a lot of maintenance, but okay. At least if everything before was have been done, in the best way technically and also in terms of process. So here we will have some definitely positive outcome. Okay, And actually, I think that was all from my side. This QR code for slides, if you want to download the whole guide, so you can follow this QR code and download it. I hope it will work because I didn't have enough time to check it. But yeah, I'm looking forward to hear your questions, to answer it. Thank you so much.
Amazing. That's a lot of insights, Alex. Thank you so much for sharing them. If you have any questions, please drop them on the Q&A bar, everybody. We'll also share the slides and this recording after the call.
Yeah, thank you. Thank you. Yeah, I also noticed that it was a mistake on slide. Thank you. I will fix it.
Yeah. Alex, just one question about quality gates. How do we, like for different roles, how do we, like for managers and QAs, how do we settle on specific metrics when we set up the quality gates? Is there a good practice that we follow?
I'm not sure I got your question. Can you please elaborate more?
Yeah, for QA managers and for SDETs, the metrics would be different. So how do you choose which metrics would be ideal in this case when you set up quality gates, like you were mentioning?
Yeah, actually, it's from the first part of the talk. So, as I said, I always start from what is our goal for the next quarter, months, 1 month, the year, so I can understand high level picture. Because, as I said, the most popular problem I have been faced with it's when, in general, QA automation engineers wrote a lot of automated tests, but there is no. I mean, first of all, it's not a part of CI/CD pipeline. So we have automated tests, but it doesn't measure anything. It doesn't affect on the whole process. It doesn't affect on the release process. So it just somewhere standalone we have automated tests. That's all. So that's why it's important before we start to automate something, because automation is just a tool. It's just a way to make manual process a bit more faster. So we should ask what we want to achieve by with test automation. So that's why it's important to start from the business, from the product metrics, and when to build quality metrics, and when to try to use test automation as a tool to achieve these quality metrics. So I would say, from my experience, it's the best approach. And in this case, you really build this kind of the same language with business, because they understand why they have test automation, and you understand why you have test automation for business and how it affects business. Because somehow that's why even like QA automation engineers a lot of face with problem when they don't know how to present their work outcome. Like, okay, you wrote a lot of lines of code, but how it affects business. So yeah, I think this algorithm I presented today, for me personally, really useful.
And thank you so much, Alex. Thank you for your time.
Thank you for the invitation. Thank you, and have a nice day.